Hi, I'm Debbie Nelson with Nixene Publishing, and we're back for more graphene conversations with Adrian Nixon. He serves as the editor-in-chief of the Nixene Journal. He's located over in England. I'm coming to you from the United States. Adrian, welcome.
Hello, Debbie. Nice to see you again.
Nice to see you too. I love the topics that we touch on because some of them just blow my mind. And this one is in particular very fascinating. So we're going to be talking about graphene oxide
Yep.
and how it relates to cutting metals, in particular titanium. And I think you said this research that we're going to talk about came out of MIT.
Yeah. So, yes, graphene oxide is a sister material of graphene, and you could think of it a little bit like rust is to iron. So iron oxide is rust, graphene oxide is graphene, except rust just crumbles apart. Graphene oxide is just as strong as graphene, pretty much, but it has a different range of properties, one of which is graphene doesn't disperse in water very well, but graphene oxide does. So you can mix it with other things. And in this particular case, what we're looking at here is something fairly humble that engineers are quite familiar with, which is cutting fluids. And for that, I'll need to go to share my screen again, Debbie, if that's all right.
Wonderful.
So we'll go to another white screen again and then crack on. So this graph here shows you some data that's been found by adding graphene oxide to the cutting fluids that are used in lathes when they're machining various metals. In this particular case, this is looking at really high quality titanium alloy that's used in the aerospace industry. And it's particularly hard to machine. So you can imagine, like you would whittle a piece of wood with a penknife, you're doing something at very high speed with one of the bit of stick that you're doing spinning around very fast, and the penknife is the blade which cuts bits of metal very precisely off. The problem is they get very hot and wear out, and the tools don't last very long. So you have to put in cutting fluids, which are a mixture of oils, waters. They're quite sophisticated things, actually. They cool down the cutting heads and the material you're cutting, and allow and stop the tools from wearing out. But the problem is the tools do wear out, particularly on these very high strength alloys. Now, the graph you're looking at here on the y-axis, which is the vertical axis here, we're looking at the improvement in the wear of the cutting tool. So this is you can think of it as the blade. So the higher the number, the longer the tool will last. And along the bottom here, this is taking a cutting fluid and then adding different amounts of graphene oxide to it. So here we've got 0.1%, 0.3%, 0.5%. Do you notice anything about that pattern, Debbie?
Well, it improves the ability to work efficiently. The problem is that you've got a low amount at the beginning, you add a little more, and you have a much higher, but then you're dropping back down to...
Yeah, exactly. This happens a lot in all sorts of different applications, not only with graphene, but lots of other materials too, that you do get an optimum where you start off from a low point, then the more you add, it gets better and better, but then you reach a point where the more you add, the worse it gets. And a lot of the application development work and the research work is finding where that optimum point is. And this particular case, it was about 0.3%. But if you look at the numbers on those bars, they're all, sort of 11.01% improvement, 22.5% improvement, 20.5% improvement. These are all double-digit improvements in the performance of the tool. So, this is really significant stuff. The graphene oxide being added to the cutting fluid is really making a big difference. It's quite cool.
Pick anything and improve it by almost 25%. That's a huge improvement.
Yeah. So this is a really big deal if you're in the aerospace industry, or if you're in any industry where you're working metals with cutting fluids and you've got a problem with the tools wearing out. It might be worthwhile just checking to see if you can add some graphene oxide to your cutting fluid and see if that sort of extends the life of your tools. And it would also improve the performance of your entire process. You might need to work with a university lab, GEEK or one of the other university labs in the world, because that's the sort of thing that they do. But yeah, it sounds humble, but actually it makes a big difference, big improvement.
So you can just add the graphene oxide to what you're using already if you had the right proportions to get that kind of effectiveness.
And if you know how to mix the graphene oxide in with the fluid itself, because it's not just as simple as getting some powder and putting it into a liquid. In this particular case, they used what's called ultrasonic mixing to actually make sure that the whole thing was dispersed very evenly. So you really want the graphene oxide particles to be very, very well dispersed throughout the liquid. And the reason is we think what's going on here. The reason it's working is the graphene oxide is helping take away the heat. So the nanoplates are playing past the parcel with heat very efficiently and very quickly, and that's keeping the cutting tool tip cooler and improving the heat transfer in the fluid.
That's because of the graphene. That's
Yeah.
fantastic. Now, as a question so you're working with titanium in this particular research. Do you think it would take a different amount if you were working with a different kind of metal that wasn't as hard as titanium?
That's a really good question. The answer is probably yes. That peak and the hump of the peak might be in a slightly different place, and that's what you would pay your technical service people to do the work to find out. So yes, you're right, Debbie. You can't just sort of assume that when you're machining one metal, you need that amount of graphene oxide. You might need to have a different mix for different metals. Yeah, good question.
Interesting. And is anybody bringing this out of the lab yet into anybody?
Yes, I know one aerospace company that everybody will have heard of, who is very aware of this and applying it right now. But for obvious reasons, we'd better not say who that is.
Sure. It's definitely something to keep your eye on if you're working with metals and
Yeah.
cutting them for any reason. Gosh.
Yeah.
Well, I appreciate your time, and we'll be back again with more about graphene and, of course, the one on graphene oxide.